Alright, in this video I'm going to be working BCHW7.2 and I am recording on new software on a different computer at work. This is not my usual MO, so I don't really know how this is going, or honestly even that I'm recording at all. Alright, I'm going to start over here and I'm going to say, alright, let f prime be this, let f of 1 equal 5, find the value of f of 2. Alright, so f of, oh, this is not that great. Okay, but I'm just gonna, f of 2 equals f of 1 plus the integral from 1 to 2 of f prime of x dx. So 2x plus 3x squared dx. All right, I don't even see how a person's supposed to pause this recording. Let's see. It's definitely screen capturing. I see that. I don't know if pause is an option. Maybe I think I used that a little too much. Anyway, so all right. This is not one I'm going to be doing with a calculator. I don't know if the calculator questions are going to be labeled as such, but I'm just going to kind of go for it. 5 plus antiderivative. Okay, that's going to be 5 plus. Okay, when I plug in 2, I'd get 4 plus 8. When I plug in 1, I get 2. Okay, that would be a safe place for us to stop, but I think we can add 5 plus 10 and get 15. All right. We're going to suppose an object moves along with x-axis with velocity v of t here for t greater than or equal to 0. Position of the object at t equals 0 is -2. What is the position at t equals 1? Okay, so x of 1 is going to equal x of 0 plus the integral from 0 to 1 of the derivative of x, which would be velocity, 1 plus e to the -t dt. All right, and then I'm going to say anti-differentiate. Plug in the bounds of integration, subtract. Okay, so -2 plus. All right, when I plug in 1, I'd get 1 minus e to the -1. When I plug in 0, I'd get 0 minus 1. All right, and this could be simplified or it could be left the way it is. I'm just going to leave it the way it is. All right, if f is the antiderivative of x squared over 1 plus x to the 5 with f of 1 equals 5, then what is the value of f of 4? Okay, so f of 4 equals f of 1 plus the integral from 1 to 4 of f prime. Now, if f is the antiderivative, then the derivative would be the fraction. Okay, so that's x squared over 1 plus x to the 5 dx. And then from here, that's the type of thing I'm going to need to use a calculator for. So I'm going to kind of hop over to Desmos. F of 1 is 5. Okay, so then I'm going to say, all right, this is going to be 5 plus the integral, and we can get that out of functions. You can also type in int. Okay, I've kind of lost track. Okay, I'm going to have to flip back really quick. Say 5 plus the integral from 1 to 4. Okay. From 1 up to 4 of, it's a fraction, it was x squared divided by 1 plus x to the power of 5. Now, I am going to double check that and make sure, okay, I'm going to say, okay, right here, I've got x squared over 1 plus x to the 5. That looks right. Okay, and I need a dx, so I'm going to type that there and then get 5.376. All right, 5.376. All right, now the graph of y equals f prime of x consists of 2 line segments and a semicircle as shown in the figure. Suppose f of 2 equals 1. Find the values of f of -2 and f of 8. I'll start with f of 8. That sounds a little easier. F of 2 plus the integral from 2 to 8 of f prime. Okay, Okay, and then I'm going to say, okay, what am I going to do here? Oh, and I need to actually do the geometry here. The integral from 2 to 8 is going to be, okay, I'm thinking about this triangle right here. That's half of 4 would be 2. And then over here, the area under this thing, this is going to be like a rectangle minus a half circle. So this rectangle has a width of 4 and a height of 2, so that would be 8, and then minus half of a circle, pi radius of 2 squared. Okay, that's going to be a, if you wanted to call that 11 minus, that'd be 4 pi over 2, 11 minus 2 pi, that would be accurate, but certainly not, mandatory. F of negative 2 is going to equal 1 plus the integral from 2 back to negative 2 of f prime. Okay. And now the integral from 2 back to negative 2 would be the negative of the integral from negative 2 to 2, so that's going to be, okay, this would be positive 1. Okay, 1/2, 2 times 1, yeah. So that's 1, and then this triangle here, just going for all of it, has a width of 3 and a height of 2, so that would be negative 3 units of area in here and positive 1 units of area here. So net, that integral would be negative 2, but I'm integrating it backwards, so really what's happening here is 1 minus negative 2, and that's going to equal 3. And you can think about, okay, if f of negative 2 is 3, and then we integrated f prime, that would give us the net change in f, and we got negative 2. That brings us down to the 1 that we knew we were supposed to have at f of 2. All right, so now over here, this one's from 2022. The graph of y equals f prime consists of a semicircle and 2 line segments shown in the figure. Find the x-coordinate of all points of inflection, justify my answer. Okay, this is the graph of y equals f prime of x. Okay, so point of inflection, I'm going to start with the reason. F double prime changes signs. And f double prime is kind of, that's the slope of the graph we're looking at. And that would be at x equals 2 and x equals 6. Okay, then let g be f of x minus x. On what intervals, if any, is g decreasing? Okay, well, g prime of x, which I know is f prime of x minus 1. Okay, and I'm interested, if I want decreasing, I want that first derivative to be less than 0. Okay. And then I will say, all right, well, that's like saying f prime of x is less than 1. And, okay, well, I'm going to go over here and say, okay, here's where f prime of x is equaling 1. Okay, and if we want less than 1, well, that would just be everything before x equals 5. Okay, so x is less than 5 there. Okay. And all right, find the values of f of 0 and f of 7. Okay, well, what do we know? That's gonna be tough without an actual value of f. What am I missing here? Okay, I'm just gonna make something up. I'm gonna say the value of f of 4 equals, let's see, 3. And I'll make sure to update that on the original document. Yeah, f of 4 equals 3. That'll work. That'll be just fine. All right. So then f of 7 is going to equal f of 4, which I'm now calling 3, plus the integral from 4 to 7 of f prime. Okay. So what's going to happen here is I'm going to say, all right, the integral from 4 to 7, you could look at this as a trapezoid or something. I'm just going to cut it up into, a square and 2 triangles. Okay, this triangle is 2 by 2, so that would have an area of 2. That's going to be 1 and 1, so that's 0.5 worth of area, and there we go. All right, so 2, 3.5. So 3 plus 3.5 is going to be 6.5. If I want f of 0, that's going to be f of 4 plus the integral from 4 back to 0 of f prime. Okay, then I'm going to say, all right, well, what is this? This area is 1/2 pi radius of 2 squared, because it's like the other one, it's going to be 2 pi. All right, so normally, okay, the integral from 0 to 4, maybe I'll actually write it like that. The integral from 0 to 4, that's negative 2 pi. Okay, so since I'm subtracting negative 2 pi, that'll give me 3 plus 2 pi. Right now, also from 2022, a sphere of ice is melting. At time t, radius is given by r of t, which is twice differentiable. R is measured in centimeters, t is measured in days. All right, if we're approximating r prime of 2, we're going to do rise over run on the table. We're going to say, wait, that can't be right. I think rather than r prime, I think we wanted to say r double prime. Okay, whoops. Okay, but hopefully by the time you're watching this, maybe it's fixed. So r double prime of 2, we're going to approximate that using, because otherwise you'd be doing like a linear interpolation, and that's not calculus. So r double prime of 2 is going to be approximately, okay, rise over run, negative 5.0 minus negative 6.1 divided by 3 minus 0. I've got all that. That's great. Indicate units measured, centimeters per day per day. Units of r prime divided by units of t. All right, use a right Riemann sum to approximate the integral, and then using appropriate units, interpret the meaning. All right, so right Riemann sum, first one is going to be width of 3, use the right edge for my representative, negative 5. Plus 3 to 7 is a width of 4, use the right edge for my representative for the height. Plus 7 to 10 is a width of 3, negative 3.8. 10 to 12 is a width of 2. Use the right hand side for your height representative. All right, that's my, what do I say in here? That's my Riemann sum. Okay, now if I want to think about this, we know how to do this. It's going to be r of 12 minus r of 0. Okay, r is measured in centimeters. Oh, that's the amount that the radius changed by over the course of, time 0 to 12. Okay, so this is going to be the net change in radius of the sculpture in centimeters between t equals 0 and t equals 12 days. Remember, we do need that time component in order to, earn those interpretation points. All right. Now, here we've got some related rates. Yep, you see the volume formula off to the side. That's probably a good sign that we're going to be taking a derivative. We're asking what rate is the volume of the sphere decreasing at t equals 7. All right. So I'm going to take the derivative of this volume formula. And then the radius is 50, so that's going to be 4 pi. If I square 50, that would be 2,500 dr dt. Wait a second. I think I can get dr dt from the table. Yeah, I've got a table of r prime values. So at t equals 7, that's negative 4.4. I'm just going to put that in there. So negative 4.4, and that is an expression for dv dt. Okay, that didn't say to indicate units measured, but that would be cubic centimeters per day. All right, now here we've got a calculator question, and so we've got Stormville and a cylindrical can of radius 10 millimeters. All right, it's initially empty, and rain enters the can during a 60-day period. The height of the water in the can is S, S of t is measured in millimeters, and t is measured in days. The rate is going to be S prime of t equals this. Okay, so that's what I really am interested in plugging into Desmos. Okay, now, actually, I forgot. I think I do have the ability here to kind of split screen. Yes, that's what I want. And then, okay, yeah. I should have had it like this the whole time. Oh well, you live and learn. All right, I'm typing in S prime of t over here, but maybe I'll just call it F of t, okay, rather than, I don't know what, I don't think I have any experience defining a derivative. I probably would not recommend that myself. 2 sine of 0.03 t plus 1.5. Okay, so I've got that. Now, I might just go ahead and make sure that I am in radian mode. I'm just very paranoid about that, but, oh yeah, 0.03 t, that's going to make it grow very slowly. Okay, now according to the model, what is the height of the water in the can? Okay, so that's where we're going to need to integrate S prime. All right, so for 0 to 60, and it started out empty, so the initial height was 0. So we're going to add 0 plus the integral from 0 to 60 of S prime of t dt. Okay, so we're going to go down, grab our integral from 0 up to 60 of f of t dt, and that's going to equal 171.813. Okay, then according to the model, what is the average rate of change in the height of the water of the can over the 60-day period? Show the computations that lead to my answer. Average rate of change. Okay, so that would be, I could find, well, I guess if I've already got the height of the water in the can at the end of the time period, it wouldn't make a lot of sense for me to reintegrate. That's the height at the beginning divided by 60 minus 0. All right, and the units of measure would be the units of S, millimeters, divided by the units of T, days. Okay, so millimeters per day. All right, assuming no evaporation occurs, at what rate is the volume of the water in the can changing at time t equals 7? Okay, yeah, but what's the, oh, that's where they gave us the radius. Okay, I kind of wondered about that. Okay, radius is always equal to 10. So that means the dr dt is 0, and I could just like kind of plug in on that fixed quantity here. Okay, so dv dt is going to equal pi times r squared times dh dt. Okay, now dh dt is s prime of t. Okay, and I'm kind of running out of room and writing a little large, but I'm interested in f of 60. Oh, no, it's not at time t equals 60, it's at time t equals 7. Okay, well, that's a pretty easy fix. I hope that's not visible, this like camera icon. Okay, it really will not go anywhere. Okay, f of 7. Okay, so that's going to be 100, maybe I'll say at t equals 7. And 100 pi multiplied by 1.91692. Okay, and this one's calculated. So, we could plug that in. I'm just including a few extra decimals just in case, because I'm not going to simplify my answer. All right. Now, the graph of y equals f of x is shown here. Let g be the integral from -1 to x f of t dt. Okay, critical point is going to be where g prime, which I'm going to remind everyone watching I know is f of x, is equal to 0 or undefined. Let's see, x equals -1 and x equals 3. Okay, I don't think I am exactly needing the split screen anymore, but I don't know how to get to stop split screening, so I think I'm stuck here. Okay, that's fine, though. I think I've got, yeah, that's clearly a calculator question later, and then, okay, we're getting close to the end. I need to get closer. Okay, so x equals -1 is going to be a maximum because g prime equals f went positive to negative. Okay, and then x equals 3 is a minimum because g prime, which equals f, went negative to positive. Okay, I definitely didn't leave enough room for that problem. Find the absolute minimum value of g on -4 to 5. Well, okay, so g of -1 equals 0 pretty clearly because it's just the integral from -1 to -1. All right, the integral from -1 to 3 is going to be, again, this is a half circle with radius 2, so we found the area of that now 3 times on this homework. That's going to be 2 pi. It's beneath the x-axis, so I'm going to say, you know, I've accumulated -2 pi of area. Okay, then at 5, I'm going to have the -2 pi plus 1/2 2 times 4. Okay, so that's not going to be my minimum. But then I need to also look at f of, or g of -4. Okay, this is kind of backwards, so I'm going to just say this is the integral from -4 to -1, but made negative. Negative of 1, 2, 3 is my height, 1, 2, 3 is my width, negative of wait, no, that was just going to be positive 4.5. Okay, yeah, 9 divided by 2, so that's negative 4.5. I know that -2 pi is more negative than -6, so the absolute minimum value of g is going to be right here. Okay, now, I might, you know, just remind everyone that I'm interested in these, x values, because these are places where g prime, which is f, is equal to 0. You know, we already actually established that on part A of this problem, but, you know, never hurts to just remind everyone. You know, it says justify your answer, so I might as well do it. Okay. So now we've got rate of change in the number of fish in a lake. So I'm going to store this equation as r of t equaling 16 plus 15 sine of pi, that's got to be over here, yeah, pi over 6 t minus 2 to the power of 0.1 t squared. Interesting function. Okay, and all right, well, it looks like we're just pretty much interested in, oh no, okay, but it's not the end of the world. Just undo my error, and okay, I've got the whole thing. This is great. I was thinking about restricting the domain, but I don't think that's going to be necessary. All right, so is the number of fish in the lake increasing or decreasing at time 5 a.m.? Well, r is the rate of change of the number of fish, so I'm just going to check r. We're switching back to black. R of 5 equals, so let's just check that. R of 5 equals 2843, which is greater than 0, and I would say increasing. Okay, then is the rate of change in the number of fish in the lake increasing or decreasing? Is the rate increasing or decreasing? R is the rate. So R prime of 5 is going to equal, I'm just going to go in here and add an apostrophe and get 2.88 1 or 880, which is greater than 0, and so I'm going to say increasing. Okay, at what time t between 0 and 8 is the number of fish in the lake at a maximum? Okay, that's multiple critical points. Okay, 6, 7, 8. Okay, so that's going to be kind of a lot. And okay, so I'm obviously going to be checking t equals 0 and t equals 8, and I'm just going to call f the number of fish. And oh man, I'm going to define a function for f. Okay, f prime of t equals r of t. I'm interested where that might equal 0, so I'm just going to kind of report these values and definitely store them. Okay, so I'm just kind of storing these. I'm going to then go back and I'm going to full computer mode here. I'm going to call this c equals, like actually define these. A equals, because I don't think I have A, B, and C meaning anything in this fish problem. Wait, that's A equals, oh wait, no, I messed something up here. That one is what wants to be B. Okay, and now you can see these values. You should definitely write this on your paper, but I'm kind of running out of room. Okay, and I think this is another one that should have come with a starting value, but it's all right, because what I'm going to do is I'm going to start integrating from 0 to, let's just do A, r of t dt. And so, okay, 0, okay, well there's, I guess maybe I'm saying change in fish. Okay, well, there's been no change in fish at time t equals 0 because we just started paying attention. When we get to t equals a, we're at plus 15. 853. Okay, then if I go back and replace this with b, that's going to be 14.894 or 893. Okay, that's less. And then if I go all the way to times c, that would be 20 plus 21.500 or 501. Okay, and then I also need to check time t equals 8, which is going to be net loss of -5 fish. Okay, so I'm just going to say, kind of because I'm in a hurry, t equals a, which was, oh goodness, 2488. Okay, and yeah, you would want to justify your answer much better than this, but I'm in a hurry, so I'm just going to be actually getting rid of this Desmos window. Yeah, we don't need that. Okay, now I'm going to real quickly do the other two problems, and then that will be all. Now, G prime is this half circle here. You do need to be able to recognize that that is the equation of a half circle. So, the radius is going to be 4, 4, and -4. And you can complain about it, or you can just learn it. And the choice is yours. But either way, you will be expected to know that this is the equation of a half circle. This is the graph of G prime here. G of 0 is 4. G of 4 equals G of 0 plus the integral from 0 to 4 of G prime of x dx. And this is great. G of 0 equals 4 plus, okay, that's going to be this amount of area, so it's a quarter circle. 1/4 pi radius squared, so 4 plus 16 pi over 4 would be 4 plus 4 pi. All right, here's another one we need to be able to draw a picture of, because really the thing is we don't know how to anti-differentiate this. So what I'm going to do is I'm going to sketch my graph and say, okay, that's 2 up here, -2 down here, and, okay, so G of 5 versus G of -2. Okay, and this is the graph of Oh, whoops. Well, that's just a typing error. Okay, this is a new homework, so I guess I was just working it to find all the errors, right? All right, so this is the graph of g prime, and g of 5 equals -1. What is g of -2? So I'm going to need these areas. And actually, what I'm going to do right here is I'm going to say, all right, if I integrated from -2 up to 5 on g prime of x, like on the graph, that's going to give me -4 from the square that's underneath the x-axis, and then 10 from the rectangle on the right, so that would be net +6. And I'll just hold on to that for a second. I'm going to say g of -2 equals g of 5 plus the integral from 5 back to -2 of g prime of x dx, which is saying, okay, -1 minus the integral from -2 to +5 of g prime, which is going to be -1 minus 6, and that would be -7. Okay, that is, I think, yep, that's all for this problem set. So that's going to be all for this video. Thanks for watching, and thanks for your patience as I experimented with this new platform.